Good afternoon, or good morning, or good evening, depending on where you're joining us from in the world. I'm Ruth McAvinia from the Copernicus communications team at ECMWF, and I'm delighted to welcome you to the Copernicus Climate Change Services Global Climate Highlights for 2023. In a moment, we'll be hearing from the team about the climate highlights of the past year. But first, a couple of housekeeping notes for our journalists who've joined us today. First off, thank you for joining in such large numbers, whether it's your first time attending one of our press conferences or one of many visits. You can ask your questions in the Zoom chat during this Zoom meeting. Please give your name and your affiliation, followed by your question in English. We will do our very best to answer all questions in the order in which they're received. However, do bear with us if we may need to check some information with some of our other colleagues who are not directly involved in the question and answer session today on camera. In a few moments, we'll be hearing from the Copernicus Climate Change Service colleagues, the service also known as C3S. But first, we'll go to our parent Directorate General from the European Commission, the Directorate General for Defence, Industry and Space, or DEFIS. I'm delighted to welcome the Head of Unit for Earth Observation, Dr. Mauro Facchini. Mauro, thank you for joining us today.
Thank you very much, and Ruth, and thank you very much for the invitation. It is with immense pleasure that we will come the meeting today and the 2023 Global Climate Highlights issued by the Copernicus Climate Change Service, so C3S. We knew, thanks to the work of the Copernicus program all over 2023, that we would not, unfortunately, receive good news today. But the annual data presented here provides yet more evidence of the increasing impacts of climate change. The European Union is working to build a greener, more digital, and more resilient Europe. The EU, in line with the best available science, has agreed on an emission reduction of 55% by 2030, now just 6 years away. The challenge is clear. Copernicus, the Earth observation component of the EU space program, funded and managed by the European Commission, is one of the best tools available to guide our climate action, keep us on track with the goals of the Paris Agreement, and accelerate the green transition. Copernicus services are key to implement the Union's Green Deal policies to increase the sustainability of human activities and the healthiness of our environment. Without monitoring how our climate is changing and the risks that these changes will bring, we cannot plan for a climate-resilient future. The Global Climate Highlights 2023, released today, show that 2023 was the hottest year on record, with global temperature close to the 1.5 degrees limits. Highlights also provided evidence on many other records this year. The urgency of climate action has never been more important. The Copernicus Climate Change and Atmosphere Monitoring Service, C3S and CAMS, already support Europe's climate efforts by providing data and information that underpin climate change mitigation and adaptation strategies. C3S gives access to a wide range of state-of-the-art products which combine millions of satellite and in-situ observations with model outputs to produce maps without gaps, describing the state of our climate for every place on the planet at any hour. Both C3S and CAMS contribute significantly to the information that supports evidence-based policymaking, such as the latest IPCC assessment reports. Thanks to the Copernicus free and open data access policy, anyone can make use of the Copernicus satellite and in-situ observations, models, and other products about past, present, and future climate and transform them into useful insights for climate resilience. All European countries need to drive down carbon emissions, and this is an undeniable tough undertaking. But data from the Copernicus services, such as C3S and CAMS, can play an important role to demonstrate progress towards net zero. Beyond the continuation of the measurement of current parameters, the Copernicus program will also soon deploy new satellites to offer the possibility to monitor CO2 anthropogenic emissions in support of the UNFCCC climate agreement. In closing, I would like to congratulate and thank ECMWF in running C3S and all contributors for summarizing these important 2023 findings. And with that, I hand back to ECMWF colleagues for more details on the 2023 global climate highlights on C3S. Thank you very much.
Thank you very much, Mauro. And Mauro Facchini will be staying with us for the question and answer session coming later. Now, to introduce the Copernicus Climate Change Service and its work, I'd like to call on its director, Dr. Carlo Buontempo, to say a few words.
Thank you, Ruth. And good afternoon, everyone. And thank you for being here with us today. The climate of the last 12 months has been once more exceptional. At C3S, our job is to operationally provide the best available evidence about the climate around us and its alterations. Our aim is to develop and deliver actionable information for our user and the policymaker rather than blue sky research. You will soon hear from my colleagues about the details of 2023 climate and about the many records that have been broken. There are three main points I would like to draw your attention to. As Mauro stated in his introduction, 2023 has been, by a large margin, the warmest year in our record that goes back to the 1940s. Not only that, in all likelihood, we have just been through the warmest year of our history, and quite possibly one of the warmest or the warmest of the last 100,000 years. I really would like this to sing with you. This basically means that our cities, our roads, our monuments, our farms, in practice, all human activities never had to cope with a climate this warm. There were simply no cities, no books, agriculture, or domesticated animals on this planet last time the temperature was so high. This calls for a fundamental rethink of the way in which we assess our environmental risk, as our history is no longer a good proxy for the unprecedented climate we are already experiencing. Second point, for the climate of this planet to be steady, there needs to be a fine balance between the incoming radiation from the sun and the radiation that the planet emits back into space. The increase in the concentration of greenhouse gases in the atmosphere, largely induced by the combustion of fossil fuel, has altered such a balance and consequently has increased the temperature of the planet. Unless we manage to rapidly stabilize the concentration of greenhouse gases in the atmosphere, we can't expect different results from those we have seen in recent months. On the contrary, following the current trajectory, in a few years' time, the record-breaking year of 2023 will probably be remembered as a cool year. Third, there are several climate events in 2023. While several climate events in 2023 took climate professionals by surprise, the information scientists made available over the last few decades provided a very useful guidance for what we have experienced this year. Our society urgently needs to improve its ability to effectively use the information, knowledge, and data that climate science and services such as Copernicus Climate Change Service openly and freely provide. Events such as today's press conference provide an opportunity for us to support such a process. So thank you very much for your attention.
Thank you, Carlo, and thank you to you and your team for preparing today's report for the Global Climate Highlights 2023. Carlo, along with Dr. Samantha Burgess from C3S and Dr. Richard Engelen from the Copernicus Atmosphere Monitoring Service, will be available for questions after the presentation. For the key findings of the Global Climate Highlights report, I now call on C3S Senior Scientist, Dr. Francesca Guglielmo, to present.
Thank you. And thanks for the introduction. I'm presenting today the Global Climate Highlights for 2023 on behalf of the C3S Climate Intelligence team at ECMWF. 2023 was the hottest year on record. The global average temperature in the River 5 reanalysis dataset going from 1940 to present was 14,98 degrees Celsius, more than half a degree warmer than the average for the 1991-2020 reference period. This temperature was 0.17 degrees warmer than in the previous warmest year, 2016. Here we look at monthly average global temperatures, where 2023 is the red upper curve, and the previous decades are stacked below, getting progressively warmer. Last year, from June on, each month was warmer than the corresponding month in any previous year. And September was the month showing the largest departure from average in the whole Era 5 dataset. Shifting to a longer-term perspective and considering further datasets beyond Era 5, on the left-hand side shown as 5 years running averages alongside Era 5 and on the right as monthly values, we see that 2023 was the warmest calendar year since 1850, and that the increase in temperature above the average for 1850-1900, the pre-industrial level, reached 1,48 degrees. Based on different data sources, it is likely that for upcoming 12-month periods, like the one ending this month or next month, global average temperature will exceed 1,5 degrees above pre-industrial. A closer look at daily averages, here shown for the year, shows that for the first time, every day last year was warmer than 1 degree above pre-industrial. Almost 50% of the days were above 1.5. And for 2 days in November, the global average temperature was at 2 degrees above pre-industrial. Again, for the first time. This relative proportion was truly unique to 2023. The number of days warmer than 1,5 degrees above pre-industrial, something first appearing in 2015 for successive days, was record-breaking. Looking at the spatial distribution of air temperature anomalies in 2023, on the right-hand side, almost all land areas saw above-average temperatures, with anomalies of more than 1 degree, for instance, over much of Europe and North America. Air temperatures over ocean were also predominantly warmer than average, the warmest on record for several regions, as for instance, for much of the North Atlantic and the Caribbean, the northern tropical and southern parts of the Pacific, parts of the South Atlantic and of the Indian Ocean. We see a marked contrast with respect to 2022 on the left-hand side for temperatures over tropical and subtropical Eastern Pacific, illustrating the transition from La Niña in blue to El Niño in red. With El Niño emerging in spring 2023 and being officially declared by WMO in July. In connection with these exceptional conditions, heat waves, drought, wildfires, and floods were seen across the globe, often locally severely impacting communities. Now let's see how all these regions experiencing extra warmth contributed differently to the global average air temperature. On the left-hand side, you see a time series of air temperature anomalies for the years 2022 and 2023 at monthly breakdown from land above and ocean below. Without going, and the color coding corresponds to latitudinal bands shown in legend on the right-hand side. Without going in too much detail with this rather complex graph, I want to stress that the region that contributed the most to the increase in air temperature observed from May to August 2023 was the tropical ocean, here in dark green, which also played a predominant role alongside the northern extratropical land in dark red in determining the large anomalies observed between September through December. So from air temperatures over land and oceans, if we look at the sea surface temperatures during 2023, these were at global average persistently and unusually high, at record levels for the time of the year from April through December. Here in this graph at regional scale, we do see clearly the transition from La Niña to El Niño in spring in the tropical Pacific, but also a signal which is high in most oceans, in particular in the North Atlantic. Marine heat waves occurred around the globe, including in the Mediterranean, North Pacific, and much of the North Atlantic. The warm tropical Atlantic also contributed to the above normal hurricane season last year. If we go to Europe, 2023 was the second warmest year for the continent, with 11 out of 12 months showing above average temperatures. Conditions were highly variable, as we see here at monthly breakdown, with September being the warmest September on record, leading to autumn, so European autumn, September to November, second warmest on record. Europe too experienced heat waves, wildfires, and storms leading to severe flooding. From European land to polar land, the Antarctic sea ice extent, here shown on the left-hand side, daily value in a full year cycle, had February at all-time minimum for both daily and monthly averages. And it was at record low extent for the corresponding time of the year in 8 months during 2023. That's a blue curve, which lies below all previous years. On the right-hand side, we see the monthly evolution of the sea ice concentration. For your reference, the purple curve is a sea ice edge during the climatological reference period. And the concentration of the greenhouse gases, carbon dioxide and methane, here shown as column averaged monthly values over the years, continued to increase in 2023. The increase was similar to the one observed in previous years for carbon dioxide, whereas for methane, it was high, but less than for the last 3 years. And with this, I thank you for your attention. While the team is looking forward to your questions, I hand over to Ruth.
Thank you very much, Francesca. It is a grim read in many ways, but thank you for presenting it so clearly and concisely to us all. Just before we start with the questions, we want to tell you about a new product that's under development at the C3S team, and I'd like to invite Dr. Samantha Burgess to tell you about it now.
Thank you, Ruth. If we could have the slides back, please. So we've seen throughout 2023 the importance of closely monitoring our climate. And next slide, please. And hopefully the GIF is working. I'm delighted to share a new application, Climate Pulse, that C3S and ECMWF are developing, which will launch later this month. If someone could start the GIF, that would be very helpful. This new interactive tool will enable everyone to not only look at how our climate is changing, but to download and share the data and graphics, both time series and maps, both absolute temperatures and temperature anomalies, both global surface air temperature and sea surface temperatures, comparing different years and different regions to understand the climate on daily, monthly, and annual timescales. It is based on the same data that C3S uses for our climate monitoring, the Global Reanalysis Dataset ERA 5. Although ERA 5 is already available for free and open on the C3S Climate Data Store, through Climate Pulse, the data will be post-processed and available just 2 days behind real time to enable everyone to understand how our climate is changing and to start conversations about climate. Thank you.
Thank you very much, Samantha. We look forward very much to launching that product. And of course, we will let media and everybody else know through our customary channels, including social media and our email list for reporters. If you'd like to be on that list and you are not, please do contact us at copernicus-press@ecmwf.int. Now, I'd like to call on our Q&A panel to assemble. And in the meantime, if you need to use any of the graphics from Francesca's presentation, you can find them all along with the report in detail on climate.copernicus.eu. This afternoon for our panel, we are joined by Samantha Burgess, Carlo Buontempo, Francesca Guglielmo, Mauro Facchini, and Richard Engelen. For the first question, we go to George Airing's question, which is, you said it was the warmest year for probably more than 100,000 years. Could you please explain how you know this and what were the conditions when it was even warmer in former times? That's been a very popular question over the last couple of months. And I know, Samantha, you've referenced it on your LinkedIn before. Can you explain a little bit about this 100,000 years element?
Yes, of course. So as everyone on the call is aware, our data set goes back to 1940, and we combine with other global data producing centres to go back to the pre-industrial period of 1850. However, when we combine our data with paleoclimate and proxy data that's contained within the Intergovernmental Panel on Climate Change 6th Assessment Report, the IPCC report, which was published in 2021, we can look at how the recent decades compare with the last 125,000 years. Obviously, when we're comparing the very well-observed satellite era with paleoclimate data, the resolution of that data is very different. We know there were two very warm periods in our past. There was the mid-Holocene warm period around 6,000 years ago, and we know that the recent decades were warmer than 6,000 years ago, and the last very warm period was 125,000 years ago. So through using these paleoclimate records, which are contained in archives such as ocean cores, deep sea sediment cores, coral skeletons, speleotherms, so cave deposits, tree rings, lake cores, ice cores, we can reconstruct the climate that occurred when those records were being deposited and get an overview of how our climate has changed through time. However, the further back we go in time, the lower the resolution is. So we can't say, for example, that the 1st of January this year was warmer than at any time in the last 125,000 years because the resolution isn't the same. What we can do is look at what those data records say in terms of the temperatures contained within them around the world that are generally, particularly when we go back 100,000 years at the centennial scale or millennial scale, and we can say that right now we're warmer than almost all of that time period, particularly the last 100,000 years. There gets to be uncertainty in this last warm period that was 125,000 years ago. Thank you.
Thank you very much, Samantha. We're coming on to a couple of questions now related to El Nino. The first is from Gillian Duncan from The National. She asks, could you please say something about the several days in 2023 that saw temperatures 2 degrees above the pre-industrial average and how closely related to El Nino this was? Maybe I'll start with you, Samantha, again, please.
Yes, so we had an announcement in November that we had 2 days in November that exceeded the 2 degree threshold, the 2 degrees above that pre-industrial period. Again, it's important to articulate that there is a challenge in comparing the well-observed period with that pre-industrial period due to how well observed and how many satellites we have observing the Earth system. However, when we compare our data set and the records contained within ERA 5 compared with that pre-industrial period, and what the IPCC has said that pre-industrial period was in terms of global temperature, then according to our calculations, we've had 2 days above 2 degrees. Through Climate Pulse, we'll be able to monitor that regularly and enable people to understand where we're at in terms of exceedance above the 1 degree above pre-industrial, 1.5 and 2 degrees above pre-industrial. In terms of the impact of El Nino, it is part of the story. By far and away, the largest contribution to global temperatures is the concentration of greenhouse gases in the atmosphere. However, the El Nino event did start in July and continue to develop in the equatorial Pacific, connect up with the atmosphere and build around the world. So those particular days in November may have had a small contribution from the current El Nino event.
Thanks, Samantha. Then a related question from Jakob Meyer from ARD Radio. How many of the records that you mentioned would be due to El Nino, or put otherwise, would 2023 have been so special a year without El Nino?
2023 would have been an exceptional year without El Nino. When we look at sea surface temperature in particular, the temperature across the global ocean, the extrapolar global ocean. So we record the temperature between 60 degrees north and 60 degrees south to remove the icy parts of the ocean. We had record temperatures in the ocean from April onwards. So this was before the El Nino event was classified and before those teleconnections were in place to take it beyond the Pacific Basin to other parts of the world.
Slightly unusual question from Yuri Kapinus. Maybe, Carlo, you can speak to us briefly. He tells a story regarding radio frequencies and asks if there is any correlation between increasing number of radio frequencies and increasing temperature. Is there anything there?
Not that we are aware of. The things are operating in different bands, and the radio frequency have no significant bearing on it. On the other hand, this radio frequency are posing a challenge, at least some of the mobile band that are currently used, to our ability to monitor the climate, which is interesting in the sense that some of the radio frequency operate in band that used to be frequency bands where it was possible to observe the Earth from satellite. And so there is an interference, but it's not in the direction that it was suggested in the question, but rather in our ability to see the Earth from space.
Thank you very much, Carlo. We move now to a question from Clara Barata from Público in Portugal. What prevented 2023 from being the warmest year on record in Europe? I ask this because in Portugal, it was not so hot as in other areas of Europe. And having spent the summer in Ireland, I can confirm it was also not the warmest there. Samantha, what's going on?
Yes, so this is fundamentally the difference between weather and climate. So much of the data that we reported today is focused on global temperatures, and with a warmer atmosphere, that changes the position of the jet stream. So many of you have asked questions in past press conferences about the wavier jet stream and the implications of that wavier jet stream. And we really saw the implications of that wavier jet stream in 2023, where much of Europe had very mild summer conditions and had a much wetter summer than average in many parts, a wetter autumn and wetter winter. So this is it really shows the value of looking at climate monitoring at different regional scales and different temporal scales to ensure that you're not confusing weather with climate.
Thanks, Samantha. So going back to El Nino now, from Seth Borenstein from the Associated Press. Usually El Nino's warm effects are highest in the second year, late winter, early spring. This one was in summer, fall, or summer, autumn in Europe for 2023. Does that make it more difficult to attribute El Nino's share of the record-breaking heat? Is it fair to say far more of the heat is from anthropogenic warming now than from greenhouse gases and, question just disappeared off my screen. And how much more, please? Maybe we start with you, Carlo.
Yes, well, indeed, if you look at the past El Niño events that we've seen in the last few decades, indeed, you see the months following the peak of El Niño, and we are close to peak now. So looking at the prediction of the seasonal prediction model that C3S makes available, which are coming from the Global Producing Center in Europe. So that's the Met Office, Meteo France, Deutsche Wetterdienst, CMCC and ECMWF, but also enriched by the contribution of the Canadian, American, and Japanese model. All this model depict a peak of El Niño now and a rapid decline back to neutral condition in the next few months toward the spring. So we do expect the next few months to be warm and to again see a peak in the global mean temperature. What was extraordinary, as you mentioned yourself, is the fact that we have seen impact of El Niño already before in the last few months, and this is strange. But then, if you look at, and this is part of the press release, and it was presented by Francesca earlier on, where this extra heat is coming from, you realize that the extra heat this year is not only coming from the Pacific, as you would expect during an El Niño, it's coming from all other regions. In particular, extra tropical land, so Eurasia and North America being quite important in that respect, as well as from other ocean basins. So in that sense, as already mentioned by Samantha, what we have seen this year is not just El Niño. El Niño contributed to it, but is very much linked to a signal coming from the warming of the climate system. And this is something we'll see more and more often in the sense that with the warming of the climate system, more subsystem of the climate, more processes will be affected and will become potentially more intense or frequent. And this is an area where attribution becomes important, and there are a number of programs, not only Copernicus, but a number of research projects in Europe and elsewhere, who are looking at ways of attributing some of this event or some of this extra warming to climate change. And incidentally, today there is another press event in the afternoon focusing exactly on that.
Thank you very much, Carlo. Yes, our colleagues in the XAIDA project, that's the letter X and then AIDA, like the opera.eu, xaida.eu, have a report coming out later today that will detail a little bit more about attribution. And of course, that's an area of increasing interest for our scientists at C3S as well. We go back to Clara Barata from Portugal because she has a really popular question. Do you expect the global average temperature to continue to go higher even after January and February 2024? Or do you expect it might go down? Samantha, please.
Yeah, it's a really interesting and important question. So we expect the current El Niño event to peak either this month or next month. And we know that there is a lag between the peak of the event and the impact on global temperatures. So the expectation is for the first quarter of this year to continue the trend that we observed in late 2023 with anomalously warm temperatures. However, when we look at the global ocean temperature and we look at the data for early January, it's higher than it's ever been before. And we know that for this time of year, and we know that for ocean temperature, it continues to increase until March, which is the end of the Southern Hemisphere summer. And that's due to more ocean being in the Southern Hemisphere and more radiation or energy from the sun hitting the surface of the ocean. So although the expectation is that the impacts of the El Niño will dissipate as we move further on within 2024, we are really uncertain about how ocean temperature, particularly surface ocean temperature, will continue to evolve within 2024, and whether it'll follow the remarkable trends of 2023 or whether it will behave like it has done historically, where it will peak in March and then cool again.
Thanks very much, Samantha. I think that may also answer the question from Kate Abnett from Reuters about your expectations for this year and whether the current El Niño will be followed by a period of neutral or La Nina or more El Niño conditions. Just checking, Carlo, in case you have anything to add there.
No, I mean, pretty much what Samantha was saying. We do see from all this model I was mentioning before, this rapid transition from the current El Niño condition back to neutral by the end of spring. And if we look at the statistic of past events, is more likely than not that after El Niño, there will be a transition towards La Niña condition. It's too early to say. We are the predictability of summer at the end of during the winter is limited, so we cannot say for certain. But there is a sharp decline in temperature seen by all models.
Thank you very much, Carlo. Move back to the variability within different areas again. Rosa Bastero from Radio Nacional de España asks about Europe. Which areas of Europe have shown the greatest warming during 2023? I ask this because the average can hide the critical situation of some specific southern areas that are more sensitive to warming, like in Spain. What do you say, Samantha?
Yes, Rosa, you're absolutely right. So we know from the scientific evidence and from the IPCC that the Mediterranean in particular is one of the regions most sensitive to temperature change and is warming faster than many other land areas around the world. When we look at 2023 for Europe, the map is quite diverse. As expected with the wavy jet stream that we had across 2023. And looking at the map, we see warmer areas in parts of Spain, parts of France, and parts of Eastern Europe above the Black Sea. So we also publish a more detailed analysis called the European State of the Climate Report, which is published in April. And in that report, we'll go into much more detail about the variability within Europe and within 2023.
Thanks, Samantha. And of course, you can contact our press office for various maps of different areas in between the different reports that we publish. A reminder, of course, that at the start of each month, we have a monthly climate bulletin that refers to the immediately preceding month as well. A question now from Enza Tedesco from Montel News. How will these findings impact the supply and demand in the energy sector, particularly in Europe? What countries could suffer the most consequences? That's one question. Then what is the situation with the snowfall over the Alps? Sector experts in Italy are raising concerns about another year of low hydropower production. Is that to be expected? And how much do the greenhouse gas emissions need to fall to see a positive effect on climate change? So there's quite a lot combined there, Carlo, but I'm wondering if you could piece it out a little bit for us, insofar as we're able to speak to those topics.
Yes, well, I'll do my best, and let's see, then maybe we can follow up even offline if required. Well, in terms of energy demand, there are two tendencies that are quite clear. One is a tendency, especially in summer, to see a secondary peak. So demand in Europe is typically peaking in winter for heating purposes, but there's been a secondary peak emerging, especially in southern region, due to air conditioning requirement. And so we are seeing this in the energy demand. We have a strong collaboration and memorandum of understanding signed with ENTSO-E, which is the European Transmission System Operator Federation, and indeed is one of the concern. If you look at what the next few months have in store, well, there is, looking at seasonal prediction again, we do see a signal for warmer than usual climate, especially all over Europe, with the exception of Scandinavia and particularly larger in Southern Europe. There is also a wet signal over Central Europe, and this partly can go in the direction of the snow availability on the Alps. But it's clear, as we have seen in recent months, that there is a bit of a divide between the southern edge of the Alps and the northern side. We've seen a number of fun events recently reducing the amount of snow on the Alps, and this can potentially lead to a limit in the snow water equivalent, the amount of snow on the Alps in the southern side, which is one of the ingredients that led to problematic condition last year. So these are, I guess, with those I addressed partly at least the first two questions. In terms of how much the emission needs to fall, that's in a sense is a tricky question, because if you look at the system that we have, the climate system, we do know that the climate system and the temperature in particular respond to the concentration of greenhouse gases. And so until we stabilize the concentration of greenhouse gases, we cannot expect any different result. It takes a long time to remove the carbon and from the atmosphere, and this means that we are in the long period, and the sooner we can stabilize the concentration and get to net zero, the better it will be. And in that sense, even a tenth of a degree matter, and the sooner we take action, the better.
Thank you very much. We have a question from Kenza Bryan from the Financial Times, just relating to La Nina and temperature later this year. Kenza, I hope that's already been answered. But just since you mentioned greenhouse gases just there, Carlo, she's also asking about, can you talk a bit more about the slowing growth in methane concentration in the atmosphere, please? Samantha, would you like to start? Or Carlo, as you wish.
Go ahead.
I was just saying, go for it.
Do you want me to start?
I was about to suggest it, Richard. Please go ahead.
Okay, sorry for the confusion. So the methane growth is complicated to really assess what is happening. We've seen an increased growth over the last few years. There's quite a bit of scientific debate about the reasons for this. And for methane, it's more so than CO2. It's really a combination of emissions from anthropogenic activities, but also natural systems like wetlands in the tropical regions. And then, of course, natural systems are affected by global warming as well. So it's really hard to assess very rapidly. It's a debate in the scientific community to understand what is going on. We now see a reduced growth, which obviously is very positive, but to attribute this to either natural emissions or anthropogenic emissions or a combination of the two, we need more time to really look into this.
Thank you very much. Would C3S like to add to that, or are we happy to proceed? Great, thank you. So I skipped over briefly a question from Richard Delvin because we wanted to add somebody to the panel to answer this particular question. We're very happy to have an extra person joining us today from DG Klima. That is the Principal Advisor, Dusan Krenik from DG Klima. The reason is the question is a little bit more related to the 1.5 degrees and the political side of it. So I'll read it out. It's Richard Delvin from news.wickedproblems.uk. He says, at COP28, Dr. Sultan Al-Jaber called keeping to 1.5 degrees Celsius above pre-industrial levels as a North Star, reinforcing the idea that the warming limit in the public mind is a climate goal. Given the data being presented here, is it time to advise policymakers to stop talking about limiting warming to 1.5 degrees Celsius as an achievable goal? Just to describe this 1.5 degrees for a moment first, Samantha, can you just explain a little bit the background, and then we'll ask Dusan to speak to it as well?
Yes, of course. It is a really important question. And the short answer is absolutely not. So the 1.5 degrees and 2 degree limits were established by the Paris Agreement in 2015, where all parties nations around the world committed to limit global warming to either 1.5 or worst case scenario 2 degrees above the pre-industrial period. The IPCC then came out and defined what the temperature was in that pre-industrial period, and exceeding it is the long-term average. So it's not a day above 1.5, it's not a month or a year above 1.5, it's a long-term average of 20 years or 10 to 20 years, given that if the trajectory is still increasing, then we can say after 10 years that we have exceeded the Paris Agreement limit. We are likely to overshoot 1.5 degrees. That's basic physics of the system and the amount of warming that is locked into the system. However, the reality is that every single fraction of a degree matters. And we know the warmer our atmosphere, the warmer our climate, the more intense and the more frequent the extreme events are. For me, this is also an equity question. And who are we to tell future generations the type of world that they inherit from us? And that is based on ambitious climate action and getting to net zero as quickly as possible. Over to DG Klima and Dusan Krenik.
Good afternoon. I would like to add to Samantha that it's really important that we work towards our objective to limit the global warming to 1.5 degrees Celsius. And the European Union is doing everything what is possible, aligned with our ambitious goals of achieving climate neutrality by 2050 and to reduce greenhouse gas emission by at least 55% by 2030. Also, it's important that there is a cooperation on international level. And in that direction, the recent COP28 really contributes. And we need international cooperation, really still keep this objective of 1.5 alive. So we are not on the track, but still we can do it. So, but we need really broad international cooperation, and there were many achievements in the recent COP28 conference. That the goal to triple renewable energy production, also to increase progress in energy efficiency, doubling energy efficiency gains, and there were also good results on loss and damage fund, and at least there was a move to transition away from fossil fuels. So there are positive elements, but we need to step up our efforts in the EU and international.
Thank you very much, Dusan Fenik, and thank you in particular for making the time to join us today. We have a question from Bo Bouya from the Belga news agency, and it's a good opportunity to remind everybody that this meeting is being recorded and will still be available on YouTube afterwards. But just in the immediate, Bo asks, Samantha, you said the last time the global average temperature was this high, there were no, and then missed a bit. Could you repeat and explain that, please, if you remember?
Well, the short answer is the last time global temperatures were this high, there were no satellites. So we're relying on paleoclimate and proxy records to interpret and infer what the temperature was from the concentration of greenhouse gases, because we know that direct correlation between the concentration of CO2 and methane in the atmosphere and the impacts that has on global temperatures. So my background is originally paleoclimate, so it's something that's very near and dear to my heart. And the reality is that the science is very strong to understand how our climate has evolved using these paleoclimate archives, but you need a lot of them. You need to stack them together, and you need to ensure that you're not just getting a local signal from one part of the world, that the signal is consistent across the world. And a common misconception is the little ice age in Europe. That was a European phenomenon. It wasn't a global phenomenon. So although we, back, 200 years ago, you could ice skate on the Thames, that didn't have the same footprint on global temperatures. It was very much a European regional temperature dip. So it's really important to understand the difference between the local records, the regional records, and global records when we're understanding how our climate has evolved and will evolve.
Thank you very much. And as I say, the recording of this press briefing will be available on YouTube afterwards. We have a question from Annika Digrius from Swedish Radio regarding jet streams and climate change. This might be one we need to answer by email afterwards. Can I just check with the panel on that, please?
Well, maybe we can have a quick go and then articulate further by email, because they're
okay, great. So because we've mentioned the jet streams a little bit in relation to certain phenomena, she asks, can you tell us more about how the latest findings on how jet streams are affected by climate change?
Well, there has been some debate within the science community on this theory of the meandering of the jet stream. So the idea that a reduction in the strength of the gradient, in temperature gradient between the tropics and the Arctic or polar area may actually increase the meandering of the jet stream. In our analysis, and this was documented in a paper that came out a couple of years ago, we haven't seen evidence of that happening so far. And so in that sense, I would think that there is still some debate within the science community on the strength of that hypothesis. It's a hypothesis that has some merit, but it's not fully settled within the science community at this stage.
Thank you very much, Carlo. And Annika, do feel free to keep in touch with us on email about that one. We go back to Clara Barata in Público in Portugal. It's a really interesting question. We talk in the report about ocean heat waves and the various impacts of them. Do we expect the ocean heat waves to continue this year? Samantha, please.
Yes, we do, at least for the first quarter of this year. So when we look at the data for early January, we see that ocean heat content, both globally and for different ocean basins, is much higher than average for this time of year. The expectation is that these high sea surface temperatures will continue throughout the winter and spring, and then it remains to be seen if the ocean behaves as it did in the past. But with these high sea surface temperatures, we are more likely to get marine heat waves, which we observed many of around the world in 2023.
Thank you very much. Going back to Kenza from the Financial Times, this sounds like a very detailed question, so we may be answering it a bit later, but she's wondering whether you're able to attribute a rough numerical proportion of last year's warming to El Nino versus the greenhouse gas concentration. Samantha, would you like to have a go?
I can start. So generally, the positive impact or the warming influence of an El Nino event is about 0.1 of a degree. So we can see that historically in the strong El Ninos such as 2016 and 2020. We know that the impact of El Nino on global temperatures is normally stronger in the second year of the event rather than the first year. So we're still trying to disentangle the different contributing factors of the anomalous heat within 2023. So a part of it is El Nino, but not all of it. A part of it is the anomalously high surface ocean heat content. Part of it is where we are in the solar cycle. A lot of it is greenhouse gas concentrations in the atmosphere. Part of it is the Hunga Tonga volcanic eruption in 2022, which released a large amount of water vapor into the atmosphere, which again is a greenhouse gas. Carlo, Richard, please complement if useful.
Well, maybe just on the impact of the Hunga Tonga, there is not yet a full analysis of the impact, and the few papers that came out indicated went in different directions. Some suggested a significant warming in the extratropics. Some other suggested a negligible warming. So it's one of these processes that we know is potentially important, but that is not yet fully characterized.
Thank you. We have a lot of questions about what's coming up for this year. And Carlo, you mentioned that the new C3S seasonal forecast will be published tomorrow. Can you just take a break briefly to explain to us all what that is and how it might be useful for our reporters?
Yes, absolutely. So as I was mentioning in the previous question, C3S makes available the output of a variety of seasonal prediction models. So these are the seasonal prediction model coming out of the European Global Producing Center. So this is Meteo France, the Deutsche Wetterdienst, the UK Met Office, CMCC, and ECMWF itself. And on top of those models, each of these models actually is constituted by an ensemble of simulation, because these seasonal predictions are probabilistic in nature. And on top of these European models, there are contribution coming from the US, from Canada, and from Japan, and very soon also from Australia. So all this information put together are available both in numerical format and in graphical format on the C3S web pages, and journalists can look at those. They need to be interpreted in a probabilistic sense. We are unable to say what the weather will be like in a month or two exactly, but we can provide some information about the balance of probability, the likelihood of having a warmer than usual summer or a wetter than usual spring. So in that sense, the information can be used and can guide our action, especially in some part of the world, especially in those parts of the world that have a strong connection with El Niño, such as Australia, for instance, or Indonesia, or Eastern Africa.
Thank you very much, Carlo. As we mentioned, the report and that seasonal forecast coming out tomorrow can be found at climate.copernicus.eu. A couple of questions now about the Antarctic. Jeremy Wilkes from Euronews wants to know what the outlook for the Antarctic is in 2024. And Tyne Logan from ABC would like to ask, was the record low Antarctic related to the 2023 temperature specifically, or part of broader trends? May I start with you, Samantha?
Of course. So for Antarctica, ultimately, we're uncertain at this point, and we're monitoring how sea ice is evolving throughout the rest of the austral melt season, so the austral summer. So in December, we saw the daily sea ice extent shift closer to the 1991 to 2020 average after several months at record low levels for the time of year. I think it was 8 months within 2023, we had record low levels for Antarctic sea ice. The fact that we're closer to that climatological average in December is really good news, because the expectation was, when the winter maximum was so much lower than it used to be, that again Antarctica may have been transitioning into a different phase. So it's good news that it's back to that climatological average. But we and other sea ice monitoring centres will be monitoring very closely to understand what happens and where Antarctic sea ice ends up in February, March at the end of the melt season. In terms of the second question and the correlation with record temperatures, global temperatures in 2023, and how this impacts sea ice in particular, obviously when we have the high ocean temperatures, if you have warmer water sitting below sea ice, then it's easier to melt that sea ice. Antarctica and both poles of our planet are regions of very, very high variability. So when you look at a map of Antarctica or play with Climate Pulse in a week or two's time, you'll be able to see that there's often very strong red colours and very strong blue colours. And this is part of the natural variability of the system. When we look at December in particular, the anomalies for Antarctica were very, very low. So instead of it being bright red and bright blue, it was very pastel, which is really unusual. So I personally was very happy to see that, because it was an unusual signal, but it's good news for sea ice. If there's not these strong red areas, you're not likely to get that positive feedback with high temperatures and then melting. But we have to wait and see what happens. There has been suggested by the sea ice scientists that there was a phase change in 2016. So prior to 2016, there was very little signal in sea ice in Antarctica, whereas there's been a strong signal through time in Arctic sea ice. And since 2016, there's been more of a decline. Again, it remains to be seen if this is a short-term trend or a long-term trend.
Thanks, Samantha. Staying with Tyne Logan from ABC, it's a really interesting question in the context of this whole report and understanding what it means to be the hottest ever. He asks, can you please explain how the global surface air temperature is calculated? That is it reanalysis? And is it fair to look at high temperatures at select extreme temperature events throughout the year as part of contributing to the global annual temperature? So there's quite a lot of detail in there. I would mention that on the press pages of climate.copernicus.eu, there is quite a lot of information about the different systems and methods that are used, particularly with regard to temperature. But Carlo, perhaps you can mention to us now just how it's calculated and what that means.
Well, maybe I can start, but I guess Sam is the person that is closer to the topic. The main mechanism we use to look at the global mean temperature are the climate reanalysis. So this is, you can see those as a byproduct of what we do at ECMWF every day, which is to make weather forecast. And in order to make weather forecast, we ingest an exceptional amount of data into the weather prediction model. We're talking about hundreds of millions of data points getting in every day. And these allow us to constitute what we call the analysis, which is a description of the value of all physical variables for any place of the planet. So this is what we do. This is a starting point of the reanalysis. And then we can use the same mechanism, and that's what the Copernicus Climate Change Service does, to reconstruct the climate of the past. And through that reconstruction, we can characterize, again, all the physical variables for any place of the planet, and we can combine those together to get the global mean average. Then if we want to look at the global mean average in the context of what has been the last few hundred years, then there are some correction needs to be accounted for. And we typically add an offset on the anomalies that we've seen with respect, for instance, to the 1960-1990, or more recently, the 1990-2020 anomalies, to refer back to the pre-industrial period of 1850. 1900. So I'm sure Sam, you want to add further details to that argument.
Yeah, so there's a lot to unpack here. So generally speaking, our global reanalysis, which creates this map without gaps, is a 30-kilometer gridded product. So this does take weather stations. It takes effectively all observing data and combines it with a numerical weather prediction model. So by observing data, I mean satellites, I mean weather stations on land, radiosondes in the atmosphere, and buoys in the ocean as well. So we take measurements from space, from the atmosphere, from the land, and from the sea. So this is why there's often a difference between what we report in ERA 5 versus what a local weather station may say, because we're looking at a 30-kilometer grid, whereas the weather station is directly observing what the weather was at that point in time. When we look at sea surface temperature, again, it depends on the type of measurement used. So for us, the sea surface temperature that we report on is down at 10 meters to remove the diurnal cycle. So the difference between day and night, and smoothing out the radiation difference that comes from when the sun is present and when it's not. Other sea surface temperature global records use a much shallower depth at 20 centimeters. So NOAA, for example, uses 20 centimeters. So this leads to divergence. What we do though, is we compare our data set with all the other global producing centers. So this was the headline graphic that was in the press release that Francesca also showed in the presentation, to show not only the variability between years, but also show that these 5 data sets have very, very strong agreement. And the agreement was less good the further back in time you go, because our observations were fewer and our measuring was less certain. Whereas in the modern period, so since the satellite era, the differences between the global producing centers are very, very small. And there's another press release coming out later this week with NOAA, NASA, and the Met Office sharing their statistics as well. Hopefully that answers the question.
Great, Samantha, thank you very much. Thanks to Tyne for the question. We have 2 quite closely related questions from Raymond Zhang from the New York Times and Bob Berwin from Inside Climate News. Raymond asks, how do you evaluate the prospect that global warming is accelerating or could begin to do so soon, particularly given the acceleration in ocean heat uptake that has already been observed over the past 3 decades? And Bob says, there's been some public scientific discussion as to whether global warming is accelerating. Can you provide a decadal rate of warming for the last 5 decades back to 1970? So it's quite a lot of questions there, but in essential, are things getting worse and worse, Samantha?
It's hard to say is the short answer. So we can make a start, and if I haven't answered your question properly, we can follow up over email. So the temperature increase since the second half of the 19th century is estimated to be around 1.2 degrees. And there has been an average increase of 0.1 degrees Celsius every 5 to 6 years since the mid-1970s. But this rate of warming has not been steady. For example, when we look at the 5-year averages centered on the years from 2003 to 2012, They show hardly any change. This was the famous pause that many of you will remember, the climate pause. And then there was a sharp rise after that period due to the exceptional warmth of the years of 2015 to 2022 and the two strong El Niños during that period. Their average rate of temperature increase, according to ERA 5, is 0.19 degrees Celsius per decade from 1979 to 2022. That said, though, the rate of change for 2023 was outside what was expected. So whether there's been a phase shift or a tipping point, or it's an anomalously warm year, we need more time and more scientific studies to understand what's happened and really attribute why 2023 was so different from what we expected.
Thanks very much. Carlo, anything to add on acceleration of the rate?
No, I think it's just repeating really what Sam was saying is a valid hypothesis. We've seen something very unusual this year. So one possibility is that is on the edge of a distribution of climate variability. There is an oscillation on top of the trend that has been bigger than expected. But another possibility, and it is a valid hypothesis, is to assume that this has been a change in the rhythm and climate change is accelerating. We don't know yet, and as some said, this calls for further research and really to understand the origin of some of this big shift that we've seen in 2023.
Thanks very much, Carlo. We had a question via email from Tom Clark at Sky News. He asks, can you tell me where 2023 now leaves the world's warmest year rankings? I believe at the start of 2023, the previous 8 years had been the warmest on record, but this was US data. With 2023 now out in front, does that mean the last 9 are the warmest on record? I thought it would be best to use Copernicus data for the ranking. Now, this was a question we also received by email from many journalists. And Samantha, I'd like you to explain a little bit the difference between using the absolute temperature and the anomaly, and then whether we can actually do a top 10, please.
So I'm going to ask my colleagues if they could put a top 10 in the chat. But I can confirm that when we had this conference last year, we also showed the same thing, that the last 8 years were the warmest 8 years on record. There's a very slight difference in different data sets. So for us, 2023 is the warmest year on record, and it's warmer by 0.17 degrees above 2016. The next warmest year after 2016 is 2020, but some other data producing centers have those 2 years flipped. And the difference between 2016 and 2020, according to us, was less than 0.01 degrees. So that's within the almost within the measurement error. So for us, it's 2023 followed by 2016 followed by 2020, but there may be some slight differences. And I can't remember what the 4th warmest year is, but we can put it in the chat or follow up over email afterwards.
Thanks, Samantha. It's amazing that you can remember all of those off the top of your head. Just a reminder to everybody in the Zoom meeting, if you have any more questions to ask, please drop them into the chat now, as we're about to move on to the last one that we have for now, which is from Valentina Podleshna from econews.cz. Is it possible to predict which regions in the world will suffer the most in the next years from high temperatures? And if so, what are the expectations? And thank you for that. What a difficult question to tackle, but what do we know and what do we think, Samantha?
Sadly not. So we know, as I mentioned already, with a warmer world, heat waves are stronger, and so they're more intense and they last longer. However, predicting ahead of time, several months ahead of time, where those heat waves will hit is incredibly challenging. So we know that 2024 will have heat waves. When and where they occur, we can't predict, very sadly. If we could, then insurance companies would love us, hospitals would love us, because it would save people's lives. But sadly, weather and the uncertainty that predicting the weather in those long periods, several weeks to months out, is incredibly challenging. And Carlo, please compliment if I missed anything.
Well, I was just looking at the question, and I was wondering whether it refers to not just next year, but the following years. And if that's the case, I guess there is something we can say, because we do know that heat waves are already problematic in many parts of the tropics, where especially in the wet tropics, where heat waves have the potential of really causing major havoc and potentially really dramatic condition for livelihood and for human lives. So in that sense, for a combination of climate driver and also the capacity and capability of these countries to react to this condition, I guess some part of the tropical global south can be particularly at risk of heat waves in the years to come.
Thank you very much. Well, I know we have colleagues also working on Destination Earth who are addressing some of those concerns through digital twinning and modelling and hopefully finding the best ways to protect everyone in the future. For now, I want to thank everybody who has contributed today, to our panelists, Samantha Burgess, Carlo Buontempo, Richard Engelen, Francesca Guglielmo in particular for her presentation, Mauro Facchini and Dusan Hrenek, and to all of the people behind them who have helped to provide all of the information here today in this press briefing. Thank you in particular to everybody who has watched online and contributed questions. Please stay in touch with us during the year. As we've mentioned, we have monthly climate bulletins, seasonal forecasts, and still to come, the European State of the Climate in April. The recording of this will be made available, and all of the assets that you've seen today are available on climate.copernicus.eu. Thanks very much for being with us, and wish you a safe and happy 2024.